Buddy, this is Six Packs from rcgroups.com, and today we're going to be talking about building a QAV250 FPV quadcopter. We're going to be talking about just basically right now the parts of the kit that we're going to be using. I'm going to start off with the bottom plates. It's a carbon fiber frame. The two bottom plates are identical as far as all the cutouts except for one thing. One of them has the holes drilled a little bit wider and already has a set of nuts in them. It's not a locking system at all, but it's what it has. And the screws do come with blue Loctite already on them, so that's a good added bonus there. Go ahead and move on to the next one. Got the top plate, and a lot of people were mentioning the quality of the machining and cutting out of these, and I don't see a lot of issues at all. And most people say it's just aesthetics, doesn't really have anything to do with the sturdy, how sturdy the frame is. Seems pretty dang sturdy. That's the top plate, and then we have some landing gear that go on the arms. These are 3mm thick carbon fiber arms. They are very sturdy. You can get spare parts in case you do break them. Landing gear goes on. I still haven't got it on there yet. Not going to worry about that for right now. Who knows? It might bust it. Looks like a pretty darn tight fit. But anyway, 4 arms. They're all absolutely identical. No difference. No length difference. No hole cutting difference. So it doesn't matter which ones you use. They're all the same. It does have an FPV camera mount, which does mount between the bottom plate and the top plate, and has a camera mount for your Mobius, GoPro, or whatever. That does get mounted on 4 of the rubber balls to make it anti-vibration, so you get better clean video. That basically just mounts up to that, like that, on those 4 right there, but we'll get to that later in the quad build itself. Comes with standoffs, which are approximately, looks like about 35mm in length, and they attach with some screws with some Loctite on them. One thing, this kit does not come with any standoffs to mount the power distribution board or the flight control. I think that kind of stinks, but the kit that I have listed is like that. However, I do have this set that I bought for, I believe, about $13 of M3 standoffs, black and white, all kind of different standoffs, screws, washers. So should have everything I need here for that build. But just making sure that you know, if you get the kit that I have listed, that it does not come with any kind of standoffs for mounting the PDB or the flight controller. It also does not come with any wire or the harness to mount to connect your PDB to your battery. Luckily, I have a couple sets of XT60 connectors, both male and female, and here is a Turnigy 2.2 amp hour, otherwise known as 2200 milliamp hour, 35C discharge with a 45C max, and it does have that male XT60 connector on it, and of course with the balance plug. We'll get back to those batteries and everything later on in the build. And next, this is the female that I will be using for the battery. I have this 12 gauge wire that I already had beforehand, so I'm just going to use it. I'm going to end up soldering these inside of there with some shrink tubing. I only have red. It's not a big deal. There's no difference between the red wire and the black wire except for the color of the sheathing on the outside. So I'm just going to simply cut 2 lengths that I need in the red, and then I'm going to use black shrink tubing, about an inch or so on the end of each one of them, to designate which is going to be the black, which is the negative, and which is going to be the red and the positive. The propellers that come with this quad kit are supposed to be 50-30 carbon fiber. Carbon fiber, yes, very strong. 50-30s, no. This propeller here is roughly 6 inches long. So I'm guessing they have to be 630s. They look almost identical to the 6032 self-locking props that I got off Banggood. These, I'm going to be testing these. If they work out good, they're very flexible compared to the carbon fiber. The carbon fiber is not going to bend at all. Probably be more durable. Will be way easier to put on and take off. So we will worry about that also later on in the build. You do get 4 of these 3 cable servos. They're just basic servo cables, and they go on. This is the NACE 32. It's a 10 degrees of freedom. That basically means there's 2 kinds. There's a 6 degrees of freedom and a 10 degrees of freedom. They abbreviate it with 10 DOF or 6 DOF. Basically what that means, in the 6 degrees of freedom, the unit comes with only the gyro and accelerometer. The 10 degrees of freedom adds a barometer, also a magnetometer, and a pressure sensor. I can't tell you which is which. I'm pretty sure that that little device right there is the barometer. Not sure where the compass and everything is on here, to be honest with you, and not entirely worried about it. As long as it works, I don't really care. These have these straight pins on them. Thankfully already soldered, because that would have been a nightmare soldering these 30 some odd plus pins that small. So that would have been a pain in the butt. Somebody that's good at soldering can do it and not have a problem. But for maybe $5 to $10 more, you can normally get whatever kind of this you want with the pins that you want already soldered onto it for you. So that's not that big of a deal. And next we are going to move on to the PDB, otherwise known as Power Distribution Board. The one that comes with this kit is a basic generic one. It basically has just a bunch of little pads of negatives and positives. And I have my continuity tester over here from my multimeter. And I can show that touching any of the negatives together gives you continuity. Same thing with any of the positives. Yeah, you see that positive and that positive? There's no beeping, but there is on all the others. But in this one does too. That is because this specific PDB has 2 switches. So regardless to say, it's an on-off switch, and they tell you that it's most likely used for what's written on the other side. Setting up some LEDs so you can turn them off in the daytime when you don't need them, won't waste your battery, and your CCD TX, basically your video FPV transmitter. You can power it from right there. I really don't know, so that basically means that all this is going to be exactly power coming from the battery. Hopefully, I'm going to have to double check and make sure that the ESCs in this kit, that they do have a 5-volt BEC, so that I can use, basically the 5-volt would be one of the wires in this. They're basically just a plain generic 12-amp ESC. I'm just going to straight wire and strip and solder the wires together to the motors, shrink tube them, and just zip tie them onto the arms. And like I said, hopefully they do have a 5-volt BEC. I do believe it is a 5-volt 3-amp BEC in them. So should only need one of the wires. I've seen some people cut off all but the control wire. I don't think I'm going to do that. I'm just going to leave them all on unless I have problems, then I'll take them off. Those are the ESCs. The motors, 4 motors, 2 clockwise, 2 counterclockwise. And they are basically generic GLB brushless motors, 2300 kV. And the different colored tops means one's a clockwise and one's a counterclockwise. The black is the same as a normal threaded nut. You turn it clockwise to tighten and counterclockwise to loosen. And without going into greater detail, whichever way the nut will loosen is the way that motor should rotate. This one loosens counterclockwise, so this is a counterclockwise motor. That would mean because when it's turning clockwise, if you have a propeller on here and it's getting resistance from the wind and everything, it will actually, excuse me, this is counterclockwise. So when it's turning clockwise, if you put your finger on top of the nut, that's showing resistance from the propeller or from the wind, and if it tightens all the way and keeps spinning, then that's self-locking. I could prove that with one of the self-locking props. I'm not going to do that right now. Likewise, this one is backwards. You turn it clockwise to loosen and counterclockwise to tighten. Put my finger on it, turn it clockwise, and there it goes. It's tight. So this is a clockwise spinning motor. And so in other words, the silver will be mounted, would be wired straight 3 to the ESCs and the motors. So basically straight 3 right across, soldered. And then the black ones, which are going to be counterclockwise, we'll just probably just swap over these two like that and mount them, and everything should be good. Let's see here. We got the ESCs, carbon fiber props. Not sure if I covered them. I'm pretty sure I did. Here's the orange RX 615 receiver. About what, $12, and we'll be hooking that up later, a little bit later on. And I believe that should mostly do it for the time being. And that's pretty much it for the parts right now for the quadcopter. I do have quite a few other parts that will be coming in, but they will be covered in their own separate segment of when I actually install them. That would include a Bluetooth module for adjusting and setting PIDs and stuff like that in the field with my Android phone. I do have another piece for programming, if need be, the GPS module. And of course, the GPS module itself is going to have its own section so that we can use it and use the data for it, not only for your OSD and telemetry data, but also for position hold and return to home features, as well as it basically helps attitude or altitude hold a lot better with more than just a barometer. Using the magnetometer, etc., will do a whole lot better than just a barometer on its own, such as other quads like the EOX. Anyways, thanks for watching, and be looking out for the next chapter, which will be mounting the motors and ESCs on the arms of the quad, wiring, soldering it together. I'll be using shrink tubing, and then we'll move on to the next step, which will be mounting them onto the frame. Thanks for watching.